When you saw the words, "the most soothing stories about the cosmos to fall asleep to," something in you recognized what you were looking for. Not another shouting match disguised as content. Not another bright thumbnail promising panic or urgency. You wanted something older than all of that. Something that has been quietly unfolding for billions of years. You wanted the night sky, brought close enough to rest your thoughts on. Right now, as you sit back or lie down, there is ancient light still crossing space to reach you. Some of the photons that will be described tonight began their journey before your language existed, before your country had a name, before your entire family line had taken shape. Every time you tilt your head toward the sky, even if you cannot see the stars, you are surrounded by a history so long that your busiest day barely registers as a moment. You live in a world that runs on alerts, deadlines, and opinions that demand to be answered right now. Your phone, your inbox, the news, they all speak in the language of urgency. The universe does not. It moves in the language of patience. Galaxies take hundreds of millions of years to drift into new positions. Stars live for billions of years before they burn out. The structures you will hear about tonight were not rushed, and they will not rush you. You might have had a day filled with small fires to put out, a meeting that went sideways, a repair that cost more than it should have, a quiet concern in the back of your mind about health, work, or people you care about. For the next while, you are allowed to set these things gently on a shelf. You simply place them at a distance, the way a planet orbits, at a safe remove from its star, warmed by its presence, but not consumed by its heat. Tonight, you will trade the chatter of the day for something more steady. You will drift past familiar ideas, like stars and galaxies, and then slip into less familiar territory, invisible matter holding those galaxies together, a faint background glow from the birth of the universe, particles so small they pass through your body by the trillions every second. These are not fantasy. They are the facts that sit underneath everything, rarely mentioned in the rush of daily life, but always there. If you are the kind of person who likes to keep learning even when you are worn out, this is where those two needs finally stop pulling against each other. You will not be asked to remember formulas or prove anything. You will simply be invited to picture what is being described. A web of matter connecting galaxies across unimaginable distances. Empty regions of space that shape how everything else moves. And light so old, it shows the universe as an infant. The stories you are about to hear are chosen because they can feed your curiosity while your muscles loosen and your breathing slows. You may notice, as you listen, that the scale of your worries shifts. The numbers attached to your day shrink next to the distances between stars. The noise of the last email and headline fades to background. You are a brief, warm instance of awareness inside a universe mostly made of silent matter and empty space. There is also something reassuring about how consistent the cosmos is. The same physical laws that control the motion of distant galaxies also govern the arc of a dropped pen on your desk. The atoms in your bones were assembled in furnaces at the hearts of long-dead stars. When you hear about star formation, about dust clouds collapsing and igniting, You are also hearing a long, quiet preface to your own existence. You are not separate from these stories. You are one of their outcomes. So, as you settle in, you are not only listening to calming facts about distant things, you are listening to the background of your own life, the light that fills the universe, the invisible matter that shapes it, the expansion of space itself. All of it forms the stage on which your personal story plays out. Let that awareness lift some of the pressure from your shoulders. You do not have to carry the world. The universe is already carrying you. All you need to do now is get comfortable. Let your hands rest where they fall. Let your jaw unclench. Let your eyes soften or close completely. If a detail catches your interest, follow it. If your attention drifts and you miss a sentence, that is fine. This is not a race to keep up. It is a walk under a clear sky, where each new step reveals another quiet wonder. In a moment, you will begin with something simple and familiar, the stars themselves, and the first faint lights that broke the universe's long, early darkness. For now, take a slow breath in and a slower breath out. Notice how, even before the first fact arrives, the room around you has already begun to feel a little larger and a little quieter, as the cosmos makes room for you to rest inside it. When you think about the night sky, you might picture a handful of bright points scattered across a dark canvas, maybe the Big Dipper, maybe Orion's belt, maybe just a few lights from your driveway or through a bedroom window. But the truth is far larger, far stranger, and far more peaceful than anything your eyes alone can show you. You live under a sky that holds more stars than there are grains of sand on every beach, every desert, every riverbank on Earth combined. Think for a moment about what that means. Picture the sound of waves pulling through sand. Imagine billions of tiny grains slipping between your fingers. Now, multiply that image until it breaks the limits of your mind. You still will not come close to the number of stars in the universe. And yet, despite this immensity, the sky remains quiet. The universe holds its size without needing to raise its voice. Right now, the observable universe stretches about 93 billion light years from one side to the other. That is only the part we can detect. Much more likely lies beyond the horizon of what light has had time to reach us. When you hear that number, your brain may try to look for an anchor. A billion of anything is already unimaginable. A billion years ago, Earth's atmosphere was just beginning to shift towards supporting complex life. 93 billion light years is a scale so large that the human mind does not measure it. It floats inside it. But you do not need to feel intimidated by this size. It is not a reminder of how small you are. It is an invitation to let yourself loosen inside a space that does not demand your effort. As you listen, remember this: the light you see in the night sky is old. Sometimes it is very old. The glow from distant galaxies began traveling toward you before any of your ancestors spoke their first words. Some of it left its source when the continents were arranged differently, when Earth's mountains were young and unshaped by wind. A single star you notice tonight could be shining to you from thousands of years ago. That means that every time you step into the dark and tilt your head, you are not just seeing light. You are seeing time itself moving toward you, one photon at a time. But long before the stars we know today existed, There was a time when the universe was completely dark. No galaxies, no suns, no constellations. Just cooling gas in a black, silent expanse. The first stars had not yet formed. There was no starlight to break the darkness, no spark to illuminate the cold. For hundreds of millions of years after the universe began, there were no points of brightness anywhere. Imagine that, a cosmos without a single sunrise. This period is known as the Cosmic Dark Ages. It was not frightening. It was simply empty of light, the way a room feels before someone turns on a lamp. Then came the first light, the very first stars. They were enormous, far larger than anything shining above you now, and they lived fast, burned hot, and died young. They were called Population 3 stars. Pure hydrogen and helium. No heavier elements at all. They were the first engines powerful enough to end the universe's long darkness. When the first of them ignited, the universe woke up. Their light traveled outward in all directions, pushing back the dark and warming the vast cold around them. Those first stars did not last long, but their short lives changed everything. With their explosive deaths, they created the first heavy elements: carbon, oxygen, nitrogen, iron, the ingredients for worlds, oceans, and for you. This moment is often called the cosmic dawn, the universe's first morning. Everything you know comes after it. Every star in the sky, every galaxy, every planet, every molecule inside your lungs, every beam of starlight your eyes have ever caught. When you imagine that first sunrise in a universe without suns, you are picturing the beginning not only of celestial light, but of the chain of events that eventually led to life on Earth. Even now, the faint afterglow of the universe's beginning still surrounds you. That glow is called the cosmic microwave background, a soft, cold radiation filling every direction you look. It has cooled over billions of years and now sits at just 2.7 degrees above absolute zero. But despite its temperature, it carries warmth in a different sense. It is one of the oldest pieces of evidence you can ever encounter, older than any fossil or ancient artifact. When scientists look at the cosmic microwave background, they are looking at a picture of the universe as a newborn, only a few 100,000 years old. And you are living inside that faint light even now, wrapped in its ancient glow without needing to notice it. As you breathe slowly and steady your mind, imagine these layers of history around you. The sand to stars comparison that stretches your imagination. The 93 billion light-year width of the visible cosmos. The starlight that has been traveling toward you for ages. The first stars burning in a universe that had never seen light before. The cosmic dawn that began everything that would eventually lead to your presence here tonight, and the cold background radiation that still hums softly through space. These are not distant concepts. They are the quiet architecture you live inside every day. You might wonder how something so vast could feel so peaceful, how a scale that large could be anything other than overwhelming. But the truth is, the vastness is part of the peace. It is wide enough to absorb worry. It is calm enough to slow your thoughts. It is steady enough to remind you that everything, even the universe itself, had a beginning. And beginnings are gentle places. They do not rush. They simply unfold. If you feel small in this chapter, let that feeling be a comfort rather than a fear. You are not the center of everything, but you are a part of everything. The atoms in your bones and blood came from stars that lived and died long before Earth took shape. Your existence is not separate from the cosmos. It is one of its natural outcomes. When Carl Sagan said, "We are made of star stuff," he was not speaking poetically. He was describing a literal truth. The iron in your blood came from a star's collapse. The oxygen you breathe was formed in the hearts of ancient suns. You are part of the same story you are listening to. So let this chapter widen your view without crowding your mind. Let it remind you that everything begins somewhere, even the universe, and that the stars above you tonight are not only marks of light, but reminders of a story that stretches back long before anyone had a name to call them by. When you imagine the universe, you might picture stars drifting, galaxies rotating, and planets circling their suns. But the truth runs deeper than motion. It is not just that objects move through space. Space itself moves. Space stretches, expands, grows. You are living inside something that is changing every second, quietly, steadily, without any sound. And the story of that expansion begins not with a blast, but with a beginning far stranger than the word explosion could ever describe. The event we call the Big Bang is often misrepresented as a massive detonation, like a cosmic firework bursting outward from a single point. But if you were able to witness the earliest moment of the universe, you would not see a blast at all. You would see space itself emerge. The Big Bang did not happen inside a pre-existing void. It created the void. It created the dimensions that later held galaxies, stars, atoms, and everything you know. It was the birth of space, time, and the rules that govern both. A fraction of a second later, something even stranger happened. The universe expanded faster than light, not the objects inside it, space itself. This period is called inflation, a moment when distances doubled, doubled again, and doubled again in a chain reaction far beyond anything the human mind can visualize. You can picture it like a balloon being blown up in an instant, going from microscopic to enormous before a breath could even form. And just like markings on the surface of a balloon move apart when the balloon expands, galaxies move apart as the universe expands, not because they are flying through space, but because the space between them stretches. This idea can feel abstract, but let it settle for a moment. You are sitting in a universe where even the most distant galaxies are not racing through space like rockets. They are being carried by the expansion of the fabric beneath them, the way ripples move outward when a pond grows larger. When a galaxy's light reaches you from billions of years ago, that light has been stretched by the moving space it crossed, lengthened into a redder color. This stretching is called redshift, and it is one of the clearest pieces of evidence that the universe is getting bigger in every direction. The light you see is not just old, it is stretched by time itself. As you listen, imagine a balloon again. Draw tiny dots on it with a pen. Each dot represents a galaxy. Now begin to inflate the balloon slowly. The dots stay where they are on the surface, yet each one moves farther from all the others. None of them is the center. None is doing the traveling. The space between them is doing the work. This is the shape of our universe. No center, no edge, only growth. This expansion reveals something else. the remarkable flatness of the universe. In three-dimensional terms, flat means space is not curved in a dramatic way. If the universe were curved sharply, like the surface of a sphere, light beams would bend around it. If it curved the opposite direction, like a saddle, light would bend outward. But measurements show the universe is almost perfectly flat. This is surprising. Over billions of years, tiny irregularities should have accumulated, and yet the universe remains balanced with extraordinary precision. It suggests that inflation smoothed everything out in its early moments, leaving behind a universe that behaves in simple, predictable ways on the largest scales. To understand how all of this evolves, cosmologists use something called the scale factor. It measures how much the universe has stretched from one moment to the next. At the beginning, the scale factor was nearly 0, and today it is 1. In the future, it will be larger than 1. Each step upward in the scale factor pushes galaxies farther apart. When you hear about a galaxy billions of light years away, you are also hearing about the scale factor that has grown since that light was released. The space the light traveled through was smaller when it began its journey and larger by the time it reached you. Because the universe has expanded for so long, there are limits to what you can see. Light travels at a constant speed, but the space it travels through keeps stretching. This creates what scientists call the cosmic horizon. It is the boundary beyond which light has not had enough time to reach you. Not because the objects are too faint, but because the universe is too young for their light to have crossed the distance. Every year, the cosmic horizon expands slightly, revealing more of the universe to us. But there will always be a limit. Some galaxies are moving away faster than the speed of light due to the expansion of space, and their light will never reach us. They are forever beyond the horizon. Think about that for a moment. You are looking at a universe that is both visible and invisible at the same time. The part you can observe is only a small portion of the whole, and yet the horizon does not feel like a barrier. It feels like a reminder that exploration is endless, that no matter how far your curiosity reaches, the universe will always offer more than you can see. There is something calming in this story of growth. Space expands without hurry, without noise, without needing permission or approval. It simply stretches the way your chest rises when you breathe. When the day feels tight, when your thoughts feel confined, there is a quiet comfort in remembering that you live in an environment that is constantly opening, expanding, making room. Even now, as you listen, the fabric of space is stretching in all directions, enlarging the distance between the galaxies while keeping the laws of physics steady beneath your feet. This chapter is meant to give you clarity, not confusion. You do not need to picture every detail. You only need to imagine a universe that grows. Let your mind drift with the balloon analogy. Let yourself float among galaxies that ease apart like slow-moving lights on a dark ocean. Let the idea settle that nothing in the universe is static, not even the space between things. Everything is in motion, yet nothing demands your urgency. Neil deGrasse. Tyson once said, "The universe is under no obligation to make sense to you." And he is right. But sometimes, late at night, in the quiet, it does. It makes a different kind of sense. Not the kind solved with numbers, but the kind felt when you step back and breathe and see that everything is part of a long, unfolding journey. If space shapes the journey you are traveling on, then matter shapes the landscape you move through. As you drift deeper into the story of the universe, you begin to realize something surprising. Almost everything you can see is only a tiny portion of what truly exists. The stars, the galaxies, the glowing clouds of gas, the clusters of light scattered across the sky. They are beautiful, but they are only the most visible threads of a much larger tapestry. More than 85% of the matter in the universe is invisible. It does not shine, reflect, or absorb light. You cannot touch it, and no telescope can photograph it. Yet it is everywhere, forming the hidden structure that holds the cosmos together. Scientists call it dark matter, but the name only tells you what it is not what it is. Imagine the universe as a grand architectural project. Galaxies are like bricks, and dark matter is the scaffolding that keeps those bricks arranged in the patterns we see. Without it, galaxies would fly apart, unable to hold themselves together. Stars would not gather into spirals or clusters. The universe would be a loose, drifting fog of particles instead of the structured landscape you recognize. When you look at a picture of a galaxy, you are not just seeing stars. You are seeing the visible outline of an invisible framework. Dark matter forms halos around galaxies, massive, spherical envelopes stretching far beyond the edges of the stars. These halos create the gravitational pull that keeps everything from drifting away. If you could see dark matter directly, each galaxy would appear wrapped in a vast transparent shell, like a lantern surrounded by a globe of glass. But dark matter's influence goes well beyond individual galaxies. It shapes the universe on the largest scales. It forms long, delicate filaments, cosmic highways of gravity connecting galaxy clusters across millions of light years. These filaments weave together into what scientists call the cosmic web, a sprawling network of invisible strands, with galaxies gathering at the intersections like dewdrops on a spider's silk. You are living inside this web right now, inside one of its threads, held in place by a substance you cannot feel, but that shapes everything around you. Dark energy adds another layer of mystery. If dark matter pulls things together, dark energy pushes them apart. It accelerates the expansion of the universe, driving galaxies away from each other faster and faster over time. While dark matter acts like the glue of the cosmos, dark energy acts like its engine. The two together create a balance that determines how the universe grows, evolves, and spreads out over billions of years. No one knows exactly what dark energy is. It could be a property of space itself, a pressure woven into the fabric of existence. It could be something even stranger, something that lies beyond the edges of known physics. But whatever it is, dark energy now controls the fate of the universe. It is the dominant force shaping the long-term future of everything you can see. Think about that. The most powerful influence in the cosmos is something you have never directly observed. Something completely silent, completely invisible, quietly steering galaxies like leaves on a vast, dark current. Gravity plays a central role in this hidden world. You experience gravity every day as the pull that keeps your feet on the ground. But on cosmic scales, it becomes a sculptor. It draws matter into clumps, stretches it into filaments, and tugs galaxies into clusters. It even bends the path of light. When light from a distant galaxy passes near a massive object, like another galaxy or a cluster, the gravity of that object can distort the light, magnifying it or stretching it into arcs. This effect is called gravitational lensing, and it comes in two forms. Strong lensing is dramatic. It creates rings, arcs, and warped shapes, turning a single distant galaxy into multiple images. Weak lensing is subtle, shifting the shapes of galaxies by tiny amounts that only appear when thousands of them are measured together. But both reveal the presence of dark matter. Even when dark matter cannot be seen, its gravitational signature appears in the way light bends around it. It is like watching wind ripple across tall grass. You may not see the wind itself, but you know it is there by what it moves. These forces create galaxy tides, slow, powerful interactions that pull and stretch galaxies over millions of years. When galaxies pass near each other, their shapes distort slightly, like soft clay being tugged from different directions. These tidal interactions can trigger new patterns of star formation, or cause galaxies to merge gently into one another. Over cosmic time, these tides sculpt the appearance of the night sky, guiding the evolution of systems far larger than anything on Earth. As you listen, let the mystery deepen rather than confuse. You do not need to solve dark matter or explain dark energy. You only need to imagine the universe as a place where most of its structure lives in shadow. The stars you see are like lanterns hanging from invisible beams. The galaxies drift along strands you cannot touch, and the expansion of space is pushed forward by something silent and unseen. This chapter is meant to give you the sensation of looking through the darkness and realizing there is more there than you ever knew. Isaac Newton once said, "What we know is a drop. What we don't know is an ocean." In astronomy, that ocean is not empty. It is full of shapes without light, forces without names, and patterns that guide the universe with a patience far beyond human years. When you look up at the night sky, you are seeing only the surface of that ocean. Everything beneath it is hidden, yet essential. And within that ocean, galaxies drift like islands. As you drift deeper into the universe's quiet story, you begin to notice something remarkable about the grand structures around you. Galaxies are not scattered across space like random sparks from a campfire. They move with purpose. They rotate, collide, merge, cluster, and travel along invisible currents shaped by gravity and dark matter. Each galaxy is a kind of island, vast, ancient, and full of its own internal light, yet always connected to a larger flow. When you picture these motions, you are no longer just looking at the night sky. You are stepping into a dance that has been unfolding for billions of years. Start with the galaxy you live in, the Milky Way. It is a barred spiral about 100,000 light years across, turning slowly like a grand wheel in the dark. Your solar system sits far out on one of its spiral arms, traveling around the galactic center at roughly 500,000 miles per hour. Even at that speed, it will take more than 200 million years to complete a single orbit. Every time Earth circles the Sun, you also drift a little farther along that enormous galactic path. Stars, dust, gas, everything in the Milky Way participates in this long, steady rotation. You are moving through space even when you are standing perfectly still. But galaxies do not only rotate, they interact. They fall toward one another, pulled by gravity across great distances. Sometimes they skim past each other, stretching out in long tidal tails. Sometimes they collide head-on, their stars passing through like waves merging in an ocean. From a human perspective, a collision sounds violent. But on the scale of galaxies, these events unfold in slow motion. Stars rarely hit each other directly because the distances between them are so vast. Instead, their orbits shift, their gas clouds compress, and new waves of star formation ripple across the merging systems. The Milky Way itself is moving toward a collision. Across the dark, the Andromeda Galaxy is approaching at about 250,000 miles per hour. In 4 billion years, the two galaxies will meet, not with explosive force, but with a gradual intertwining, spiral arms overlapping, stars drifting into new patterns, the two galaxies blending into one larger structure. This future galaxy will be different from both parents, a shared creation shaped by their long gravitational embrace. If life still exists somewhere in those distant eras, its sky will look completely transformed, filled with new arcs of starlight created by the merger. But galaxies are rarely alone even before they collide. They gather into clusters, groups bound by gravity, containing hundreds or even thousands of galaxies. Imagine a city made entirely of stars, then multiply it by thousands and stretch it across millions of light years. That is a galaxy cluster. These clusters themselves gather into even larger structures called superclusters, enormous regions containing multiple clusters and countless galaxies. Your home supercluster is called Laniakea, a Hawaiian word meaning immense heaven. It contains around 100,000 galaxies spread across 500 million light years. Laniakea gives you a sense of where you live in the broader cosmic map. The Milky Way is not an isolated marvel. It is one point in a broad network of galaxies, all drifting together in the same general direction, as if carried by a colossal unseen tide. That direction is guided by the underlying structure of the cosmos, those vast filaments of dark matter you learned about earlier. Galaxies flow along these filaments the way rivers follow the shape of their land. They gather at the intersections, forming clusters and superclusters, then drift outward along the strands that connect them. If filaments are the highways of the universe, then cosmic voids are the wide, silent plains between them. Voids are enormous regions nearly empty of galaxies, stretching tens or even hundreds of millions of light years across. They are not truly empty. There is still a trace of matter inside them. But compared to the rich filaments, they are quiet spaces where galaxies are rare. The presence of voids shapes the flow of galaxies by giving structure to where matter gathers and where it does not. Gravity pulls galaxies toward the filaments and away from the emptier regions, creating the cosmic motion patterns we observe today. Picture it all together: rotating galaxies drifting through space, merging gently over billions of years, clustering into massive groups, flowing along invisible strands, and shaping their paths around silent voids. This motion is not chaotic. It follows slow, steady, predictable patterns. There is wonder in recognizing that galaxies move not randomly, but in response to vast structures you cannot see. You can imagine yourself floating alongside them, being carried calmly along a current formed long before Earth existed. Brian Greene once described the universe by saying, "We live in a cosmic archipelago." He was right. Each galaxy is an island of light surrounded by dark seas. Each cluster is a chain of islands. Each supercluster is a continent. And the cosmic web is the geography that holds it all. When you understand this, you begin to feel the inevitability of cosmic motion. It is not rushed. It is not forced. It is simply the natural flow of things, governed by gravity and shaped by time. As you listen, let this realization settle quietly inside you. You are part of this motion, not separate from it, not looking in from the outside, but moving with it. Your solar system orbits the Milky Way. The Milky Way moves toward Andromeda. Both drift through Laniakea. Laniakea flows along filaments of dark matter. Everything is in motion, and everything is connected. When you think of your place in the universe, this is the frame to hold on to. You are drifting through a cosmic dance far larger than yourself, but you are also carried effortlessly by it. And while galaxies are the cities of the cosmos, full of stars and light, something even more powerful lies at their hearts. Something that shapes them, fuels them, and sometimes illuminates the universe more brightly than anything else. But galaxies are just the cities. Let's visit their power plants. As you drift deeper into the structure of the universe, you arrive at places where gravity becomes so strong, so absolute, that even light cannot escape. These are the supermassive black holes that sit at the cores of galaxies, including your own. They are unlike anything else in the cosmos, silent, invisible anchors that shape the worlds around them. Every large galaxy, from elegant spirals to massive ellipticals, carries one of these giants at its center. Some weigh millions of times more than the Sun. Others weigh billions. And yet, despite that unimaginable mass, they give off no light of their own. They are the darkest objects in existence, wrapped in an event horizon where time itself stretches and slows. But around these silent giants, something extraordinary happens. Matter spirals inward, falling toward the black hole in a vast rotating structure called an accretion disk. You can imagine this disk as a glowing whirlpool of gas, dust, and shattered starlight, heated to extreme temperatures as it swirls faster and tighter. The friction inside the disk becomes so intense that it releases torrents of radiation, visible light, ultraviolet light, X-rays, turning the area around the black hole into one of the brightest regions in the universe. This is one of the great paradoxes of the cosmos. The darkest objects produce the brightest displays. A black hole itself shines nothing, yet the material falling toward it blazes with extraordinary energy. When a black hole consumes matter at high rates, the surrounding disk can outshine entire galaxies. This is what creates a quasar, a feeding black hole so luminous that telescopes detect it from billions of light years away. Think about that. Something smaller than a solar system, something built from collapse and darkness, can blaze brighter than the glow of 1 trillion stars. This is not fiction. It is the literal structure of the universe. In a universe full of patterns and quiet laws, quasars are the beacons that reveal where the most powerful cosmic engines reside. Quasars shine because matter falling into a black hole does not simply vanish. Before it disappears, it heats, compresses, and emits tremendous radiation. The inner regions of the accretion disk reach temperatures so high that they generate intense X-ray emissions. These signals travel across space for billions of years, eventually reaching detectors on orbiting telescopes. When scientists study these X-rays, they are looking at the final screams of matter in the instant before gravity claims it forever. But the spectacle does not end there. In some cases, black holes launch jets, narrow streams of charged particles that shoot out from the poles of the accretion disk. These jets can stretch for millions of light years, crossing entire clusters of galaxies like silent cosmic lighthouses. The mechanism behind them is still not fully understood, but it involves magnetic fields twisting and accelerating matter at nearly the speed of light. These jets are so powerful that they can heat entire regions of intergalactic gas, shaping the environment far beyond the black hole's immediate neighborhood. Despite their destructive reputation, black holes play a surprisingly important role in maintaining balance. Their activity regulates star formation within galaxies. When a black hole is quiet, gas clouds in the galaxy cool and collapse, forming new stars. But when the black hole awakens and begins feeding, it releases enough energy to warm the surrounding gas, preventing it from forming stars too quickly. Without this regulation, a galaxy might burn through its fuel in a short burst and fade long before its time. Black holes act as thermostats, guiding the long-term evolution of their galaxies. This balance between chaos and structure is one of the universe's most elegant designs. The same forces that tear stars apart also help create the conditions for new stars to form. The same gravity that pulls matter inward also launches jets that shape entire clusters. It is a lesson in extremes, in how the universe uses both destruction and restraint to create harmony over billions of years. As you listen, allow yourself to feel a sense of awe without fear. Black holes may be powerful, but their power unfolds slowly, quietly, and at distances so vast they pose no threat to you. They are reminders that even in the darkest regions of the cosmos, order persists. They show that light can come from the brink of disappearance, and that gravity, the force holding your feet to the ground, also shapes the largest structures in existence. Stephen Wright once joked, "Black holes are where God divided by zero." And while the line is humorous, it captures something real about how strange these objects are. They bend the rules, stretch the limits, and challenge our understanding of space and time. And yet, they are fundamental, woven into the very fabric of galaxies. Without them, the cosmic architecture would be unrecognizable. You are drifting through this chapter with a sense of controlled tension, excitement without alarm. Black holes are extreme, but they are also steady. They show that the cosmos is not only peaceful and vast, but capable of astonishing feats of energy and power. They remind you that the universe contains both quiet beauty and overwhelming strength, working together in ways that feel almost intentional. But not everything powerful is massive. Some are unbelievably small. As you continue drifting through the universe's quiet architecture, you come to a place where the scale shifts dramatically. Until now, you've been floating among galaxies, watching the grand structures of the cosmos rise and fall like slow tides. But the universe is not made only of immense things. It's also made of particles so small, so subtle, so ghost-like that you can live an entire lifetime without ever noticing them. And yet they're moving through you right now, in this exact moment. Not metaphorically, literally. Every second, trillions of neutrinos pass through your body. They come from the nuclear fusion inside the sun, from exploding stars across the galaxy, and from the earliest moments of the universe itself. Neutrinos barely interact with anything. They slip through planets, through metal, through oceans, through you, without slowing down. You've never felt a single one, but they're always there, flowing past you like a silent river. If you could freeze time for even a fraction of a second and see them, you'd look transparent, filled with endless streams of particles entering and leaving as easily as light through a window. These neutrinos are reminders of how intimately connected you already are to the cosmos. You don't have to look through a telescope or go outside on a clear night. You carry the universe with you. You move through it, and it moves through you. Carlo Rovelli once said, "Every second, a trillion neutrinos pass through you, unnoticed." He wasn't exaggerating. He was pointing out a truth so constant, you've likely never thought about it. The universe touches you continuously in a quiet and gentle way. Among these particles is an even older kind, relic neutrinos, the faint leftovers from the Big Bang. They were created in the first second of the universe's existence, long before any atoms formed, long before light could travel freely through space. They are some of the oldest particles in existence, scattered across the cosmos like ancient dust. Most will pass through you without interacting even once, but their presence connects you to that earliest moment. Every time one of those relic neutrinos moves through you, you are encountering a direct, physical piece of the universe's birth. But neutrinos are not the only particles drifting through your life. There are cosmic rays, high-energy particles born in the violent deaths of massive stars. When a star reaches the end of its life and collapses or explodes in a supernova, it throws off a storm of energetic particles that race across the universe at nearly the speed of light. Some of these particles travel for millions of years before they finally reach Earth's atmosphere. And when they do, they strike the air above you and create showers, cascades of secondary particles that rain downward through the sky like invisible sparks. You are bathed in these cosmic ray showers constantly. They are part of your environment, just like sunlight, just like the wind. You never feel them, but they pass through you and everything around you all the time. The atmosphere absorbs most of their energy, protecting life on Earth from the strongest impacts. Still, tiny traces reach the ground and even pass through your body. Some scientists believe cosmic rays may play a subtle role in shaping Earth's clouds. Others suggest they might have contributed to mutations early in the history of life, adding small changes that helped evolution move forward. Think about the long journey of a single cosmic ray. It may have been born in a star that exploded before humans existed. It may have crossed the void for millions of years, untouched by anything, until it finally met a molecule of nitrogen or oxygen high above you. That collision produces a fan of particles that drift downward, spreading like ripples in a pond. You never see them, but they arrive anyway. a constant reminder that you live inside a universe full of motion. Motion so small and quiet that you can go years without ever thinking about it. There's a kind of intimacy in knowing that the cosmos interacts with you on this microscopic scale. The same universe that holds supermassive black holes and cosmic filaments also sends delicate waves of particles through your skin, your bones, your blood. You are not separate from the vast structures you learned about earlier. You are connected to them in ways both enormous and incredibly small. Something born in a supernova could be passing through you right now, carrying with it the story of a star that lived and died long before Earth formed. This chapter is meant to give you that sense of closeness. You've heard about galaxies drifting across millions of light years and about dark matter forming massive scaffolding around them. But here, you are zooming in, way in, to the tiniest scales. You're learning that the universe doesn't just surround you. It flows through you continuously, quietly, without interruption. This is the cosmos not as a distant spectacle, but as a companion, a steady presence woven into the smallest details of your existence. If you listen closely, you can almost sense the two worlds merging, the immense and the tiny, the galaxies and the particles, the superclusters and the neutrinos. You are living between these scales, large enough to notice the stars, small enough to be transparent to particles that pass through planets as easily as through air. The more you understand this connection, the more the universe begins to feel like home. And now, to understand how all of this came to be, the galaxies, the particles, the light, and the dark, you'll travel backward toward the earliest chapters of cosmic history, when the universe was young, hot, and full of potential. To understand the present, we now travel further back, to understand the universe you live in now, its galaxies, its light, its silence. You have to step back into a time when none of these things existed, before the stars, before the galaxies, before even the first atoms came together in the form we know. The early universe was a very different place, crowded with energy, but empty of structure, full of light, but unable to let that light move freely. And in this chapter, you are going to drift back into that era as gently as if you were flipping through the earliest pages of a family photo album and seeing the very first image ever taken. About 380,000 years after the Big Bang, the universe experienced an event known as recombination. At that time, the universe was still incredibly hot compared to today, but no longer too hot for electrons to combine with protons and form the first neutral atoms. Until recombination happened, photons, the particles of light, were constantly bouncing around, scattering off free electrons the way headlights scatter through thick fog. The universe was not transparent. Light could not travel in straight lines or escape its surroundings. But when recombination occurred, the fog lifted. Suddenly, electrons and protons locked together into neutral hydrogen atoms, removing the main obstacle that had kept photons from traveling freely. In a single moment, the universe became transparent. Light that had been trapped was finally able to stream out in every direction, beginning journeys that would last billions of years. This ancient light is what we now call the cosmic microwave background, or CMB. The CMB is not bright. It is not something your eyes can detect directly. Instead, It is a soft, cold glow, just 2.7 degrees above absolute zero, that fills every corner of the cosmos. If you could see it, it would appear as a warm, faint light surrounding you equally from all directions, like the glow of embers long after a fire has gone out. And yet, despite its softness, it contains extraordinary information. It is the oldest light we can see, a snapshot of the universe as an infant, still wrapped in its earliest structures. The CMB is not perfectly smooth or uniform. It has tiny variations, small differences in temperature and density that appear as faint spots when scientists map it. These variations are only tiny fractions of a degree, but they carry enormous meaning. They show where matter was slightly thicker or thinner in the early universe, forming the seeds that would eventually grow into galaxies, stars, planets, and everything we know. If you study those variations, you are looking at the first faint outline of the cosmic web, the earliest blueprint for the universe's architecture. These patterns also carry polarization signals, subtle orientations of the light waves that tell us about how matter moved and interacted in those early moments. Like ripples frozen in a photograph, these polarization patterns hint at ancient motions, gravitational waves, and the tug-of-war between light and matter. They give scientists a way to peer into the earliest fractions of a second, long before recombination, long before atoms, long before the universe was even transparent. But recombination was only the beginning. After the universe became clear and the CMB was released, there was still no starlight. Hydrogen atoms floated through space, gathering slowly under gravity. The universe entered a quiet era, a long, dark stretch with no sources of visible light. This period lasted for hundreds of millions of years. The matter in the universe was cooling, settling, and preparing for something new. Then, gravity began its slow but unstoppable work. Tiny variations in density allowed some regions of matter to clump together more strongly than others. These clumps grew into larger clouds. Over millions of years, these clouds collapsed under their own weight, heating up as they tightened until the first stars ignited. And with the ignition of those first stars, the darkness ended. This moment is called reionization, the second great transformation of the universe's light. The massive early stars poured out intense ultraviolet radiation, stripping electrons off hydrogen atoms throughout space. The universe became ionized again, but this time it stayed transparent. The starlight carved out vast bubbles of clarity that expanded and merged, gradually lighting up the cosmos. What was once a cold, dark expanse grew brighter, more structured, and more alive. Reionization was not an instant event. It was a slow, wave-like illumination that swept across the universe over hundreds of millions of years. Each new star, each early galaxy, each cluster contributed to the growing brightness. The cosmic fog was burned away, leaving behind a universe that could transmit light freely and form the structures we now observe. When you look at distant galaxies today, you are seeing the descendants of those first pioneering lights, the seeds of cosmic structure. Those tiny temperature variations in the CMB grew into a vast network. Quantum fluctuations, microscopic and random, were stretched by cosmic inflation into the first outlines of the universe's geometry. These fluctuations became the scaffolding for everything else. Where matter was slightly denser, gravity pulled it in further, forming clouds, then stars, then galaxies, then clusters. Where matter was a little thinner, voids appeared, great empty regions that shaped the flow of galaxies around them. When you think about the CMB, think of it as the universe's first portrait, the earliest picture ever taken, long before there were observers to see it. It is soft, grainy, and low resolution by today's standards, but its importance is immeasurable. It is the ultrasound image of the cosmos, showing how everything began to take shape. George Smoot once said, "The CMB is the oldest light we can see." And when you hear that, you begin to understand the emotional resonance of this chapter. There is a nostalgia here, not for something you personally lived through, but for something that made your existence possible. The universe's early years were filled with transitions, moments when the laws of physics carved order out of chaos, when light first escaped, when the first stars broke the darkness, when gravity began sculpting the forms that would one day create galaxies and worlds. Imagine yourself floating in that early universe. The darkness around you is not frightening. It is expectant. You are surrounded by atoms on the verge of forming the first structures, by ancient photons waiting for their release, by the quiet hum of a universe preparing to burst into light. You are standing at the beginning of everything that will eventually become the sky above you, the atoms within you, and the stories you are listening to now. And as the stars begin to ignite in that early darkness, you feel the shift from silence to glow. You watch as the first galaxies gather, forming in the places rehearsed by the faint variations frozen into the cosmic microwave background. It is a moment of soft transformation, like dawn spreading across a landscape still wrapped in shadow. But stars are more than light. They are factories. When you look up at the night sky, it's easy to think of stars as distant decorations, bright pinpoints against a dark backdrop. But stars are far more than lights. They are factories. They are forges. They are cosmic engines that transform simple ingredients into everything complex, including the atoms inside your body. In the story of how stars build, shape, and distribute the material for worlds is one of the most comforting truths the universe offers. Because when you trace those ingredients back far enough, when you follow them through their long journeys, you arrive at a simple realization. You come from this. Before a star is born, it begins as a cloud of dust and gas drifting through space. These clouds are cold, quiet, and surprisingly fragile. Dust, microscopic grains of carbon, silicates, metals, and icy molecules, plays a crucial role in helping these clouds collapse. Without dust, the gas in these clouds would stay warm, too warm to compress under its own weight. But dust radiates heat efficiently into space, allowing the cloud to cool. As it cools, gravity begins to pull the material inward. The cloud contracts, forming dense clumps. And within these clumps, the pressure rises until the very center ignites. That ignition is the birth of a star, a transformation from a cold, drifting cloud into a glowing sphere of nuclear fire. Dust, in its quiet way, makes this possible. It is the midwife of starlight. Once a star forms, its chemistry depends on what it inherited from the universe. The first stars, as you learned earlier, had only hydrogen and helium to work with, but later generations of stars contained heavier elements: carbon, oxygen, nitrogen, silicon, iron, created by earlier stars and scattered across space by violent supernova explosions. These heavier elements are the raw materials for everything solid: planets, moons, rocks, oceans, living cells. Inside a living star, nuclear fusion rearranges the simplest atoms into more complex ones. Hydrogen becomes helium. Helium becomes carbon. Carbon becomes oxygen. Each step involves heat and pressure beyond anything you can imagine. But the result is simple and elegant. Stars build the periodic table piece by piece. In their cores, they are mixing bowls of creation, recycling the universe's lightest elements into heavier and richer ones. But stars cannot hold on to these elements forever. When a massive star runs out of fuel, its life ends in a supernova, a brilliant and catastrophic explosion that throws its newly forged elements across space. In that explosion, even heavier elements, gold, silver, uranium, are created in fractions of a second. These materials scatter into the surrounding galaxy, settling eventually into new clouds of dust. From these enriched clouds, new stars form, new planets take shape, and the cycle continues. Imagine that cycle. Dust cooling a cloud until gravity takes over. A star igniting. Fusion beginning. Elements forming. A supernova spreading those elements outward. New dust forming. New stars emerging. Planets coalescing. Oceans filling. Life taking root. All of it connected. Each stage leading to the next. It's not just a poetic loop. It's the literal history of the material you're made of. Dust is at the heart of this story, and it has shaped you in more ways than one. Those tiny grains, microscopic and delicate, gathered into larger clumps that formed the building blocks of planets. Over time, dust aggregated into rock, and rock into worlds. On Earth, this dust became mountains, rivers, crust, oceans, and eventually the chemistry of life. The air in your lungs once passed through the insides of stars. The calcium in your teeth came from ancient supernovae. The nitrogen in your DNA, the carbon in your muscles, the iron in your blood. Every one of these elements was forged in stellar furnaces long before our planet existed. As Carl Sagan said, the nitrogen in our DNA, the calcium in our teeth, were made in stars. There is comfort in that truth. When you feel small, when the days feel heavy, it helps to remember you are not built from something fragile or separate. You are built from the ashes of ancient suns. Your body carries the memory of explosions that lit the early galaxy. The ingredients of your life were shaped by forces far older and more powerful than anything you face today. Even now, the universe continues this work. When astronomers point infrared telescopes at certain galaxies, they see them glowing softly with heat from thick layers of dust. These dusty galaxies are hidden from ordinary view, their starlight obscured by clouds of material. But in the infrared, they shine brightly. Some of the most vigorous star-forming galaxies in the universe are cloaked in dust, invisible in visible light, but blazing in heat. You could think of them as cosmic nurseries, places where thousands of new stars ignite in dense, warm cocoons. Dust, again, makes this possible. It cools the gas, shapes the clouds, and absorbs the light, re-radiating it in softer wavelengths. Without dust, stars would struggle to form. Without stars, planets would not exist. Without planets, life would have no home. Dust is not something to sweep away. It is the foundation of almost everything. As you let this chapter settle inside you, a quiet realization emerges. You are not separate from the universe. You are a continuation of it. A branch on a tree whose roots run deep into the oldest stars. When you hear about dust and fusion and supernovae, you are hearing about your own story, written long before you were born. There is a remarkable calm in understanding that your existence is not an accident of biology, but the unfolding of cosmic chemistry. Dust cooled the clouds that formed the stars. Stars fused the elements that formed the dust. Dust formed the planets that formed you. It is a cycle of creation so vast and so quiet that it has been happening since the universe's earliest days, repeating endlessly in galaxies far beyond your sight. And even now, those galaxies glow with heat from dust, revealing their hidden work in the infrared spectrum. You come from this. You always have, and you always will. But how do we measure all this? When you look up at the night sky, everything seems close. Stars appear only an arm's stretch away, and galaxies look like tiny brush strokes on a dark canvas. But the truth is far more humbling. The universe is so large, so layered, and so spread across time that even measuring it becomes an act of patience, precision, and imagination. If you want to understand the cosmos, you must first understand distance. Not the kind you can walk, but the kind carried by light itself. A light year is not a measure of time. It is a measure of distance. The distance light travels in 1 year, moving at 186,000 miles per second. In the time it takes you to blink, a beam of light races around Earth more than 7 times. Stretch that speed across a year, and you get nearly 6 trillion miles. When astronomers say a star is 50 light years away, they are saying its light has spent half a century crossing the void to reach your eyes. You are not just seeing the star. You are seeing its past. But measuring these distances is not simple. The universe offers no road signs, no straight paths, no fixed markers along the way. Instead, astronomers use a system called the cosmic distance ladder, a series of methods layered together like steps. Each step measures a different range, and each step depends on the accuracy of the one below it. The first rung of the ladder is parallax, the slight shift in a star's position as Earth orbits the Sun. It is a tiny movement, almost too small to detect, but precise instruments can measure it. Parallax works for the stars nearest to us. For more distant stars, astronomers use standard candles, objects like Cepheid variable stars, whose brightness changes in predictable cycles. By measuring how bright they appear from Earth, scientists can determine how far they must be. Farther still, type Ia supernovae serve as powerful distance markers. They are bright, consistent, and visible across billions of light years. Each step scales outward, building a framework that lets us estimate the distances to galaxies, clusters, and even the farthest observable regions of the universe. With distance comes time, because the farther away an object is, the older the light you receive. When you observe a galaxy 10 billion light years away, you are seeing it as it was 10 billion years ago, when the universe was young, when stars were first forming, when the cosmic structures you now take for granted were only beginning to take shape. Estimating the ages of galaxies relies on this relationship between distance and time. Their colors, their light signatures, their shapes, all reveal how long they have been growing and evolving. But there is a limit to what we can measure. The universe is not uniform everywhere, and this introduces uncertainty known as cosmic variance. Some regions of the universe have more galaxies. Others have fewer. Some areas are denser. Others are more diffuse. Because we can only observe one universe, the one we inhabit, our measurements carry the imprint of our particular vantage point. Two observers in distant galaxies might derive slightly different estimates based on what surrounds them. Cosmic variance is a reminder that the universe does not owe us perfect clarity. It gives us patterns, but not always symmetry. Distance also shapes our view through something called the cosmic horizon. This horizon is not a physical barrier, but a limit set by time. The universe has existed for 13.8 billion years, and light has a finite speed. There are places whose light simply has not had time to reach us yet. They are not invisible because they are too dim, but because the universe is not old enough for their signals to arrive. Beyond the horizon, the universe continues, but we cannot see it, measure it, or map it. It is a boundary created not by walls, but by time itself. And yet, despite these limits, the universe remains surprisingly logical. The more we understand about distance, the more the cosmos begins to feel like a structured place, a realm governed by rules we can learn, patterns we can decode, and measurements we can refine. This does not make the universe smaller. It makes it coherent. Even when its vastness feels overwhelming, its logic brings calm. You may feel humility in learning just how far away everything is. But there is also comfort in knowing that science gives us tools to measure it. You do not have to guess. You do not have to imagine blindly. The universe opens itself slowly, step by step, and each rung of the distance ladder reveals a new layer of understanding. To understand the universe, we must first understand distance. Edwin Hubble's words still echo through every telescope, every measurement, every map we draw of the cosmos. Distance is not an obstacle. It is the key that unlocks everything else. Now that we understand the maps, let's walk the landscape. After exploring distances so vast, they stretch your imagination to its limits. It helps to return to something closer. Something you can almost feel. Something that touches your world directly. The universe is not only distant galaxies and ancient light. It is also the environment around your planet, the forces that dance across the sky, the invisible currents that pass through the solar system. Cosmic weather may not make headlines like storms on Earth, but it is always present, always shaping the boundary between the heavens and your home. Begin with magnetic fields. Every galaxy has them, vast, delicate structures threading through space, guiding charged particles like invisible winds. These magnetic fields twist around spiral arms, stretch across interstellar clouds, and influence the way cosmic rays move through the Milky Way. They are weak compared to the forces you encounter in daily life, but over cosmic distances, they matter. They help shape the flow of high-energy particles, guiding them along curving paths toward or away from different regions of the galaxy. Closer to home, your own star, the Sun, creates its own kind of weather. The Sun constantly releases a stream of charged particles known as the solar wind. This wind travels outward through the solar system, carrying magnetic fields with it. When the solar wind meets cosmic rays from distant supernovae, they interact in subtle ways, sometimes deflecting one another, sometimes blending, sometimes altering the flow of particles that reach Earth. The solar wind shapes a protective bubble around the solar system called the heliosphere, a vast shield that helps block some of the most dangerous cosmic rays from reaching Earth. But even within this shield, particles still drift inward, interacting with Earth's own magnetic field. And when those charged particles become trapped in the field, following lines that arc from pole to pole, something beautiful happens. An aurora begins. If you've ever seen the northern or southern lights, you know how surreal they can feel. Waves of color rippling across the sky. Silent curtains of green, red, purple, and blue. They appear almost alive, shifting with the pace of a slow breath. But the science behind them is simple. Charged particles from the sun collide with atoms in Earth's atmosphere, exciting them and causing them to glow. The aurora is the result of cosmic energy meeting Earth's magnetic field. It is a natural display of the universe interacting with our planet in a gentle, visual way. You might be thousands of miles from the nearest galaxy, billions of years from the earliest stars. Yet here you are, watching Earth respond to the sun's invisible winds. There is comfort in that thought. Comfort in knowing the universe does not just exist far away. It touches your world with color. When the particles strike oxygen high in the atmosphere, they create green and red light. When they strike nitrogen, they create blues and purples. The shapes and motions are created by the magnetic field itself, guiding the particles downward toward the poles, where the field lines meet. Every aurora is a dialogue. The sun speaks, the earth answers. You might think of it as weather, cosmic weather, but it is also a reminder of the quiet relationship between your planet and the stars. The Earth is not isolated. It is part of a system, connected by invisible threads of magnetism and energy. The same forces that shape cosmic rays, guide particles across the galaxy, and influence the structure of interstellar clouds also create delicate displays of light right above your head. The aurora is Earth's way of dancing with the cosmos. Whoever first said that understood the gentle truth of this chapter. The dance is slow, graceful, and full of color. It is not violent or chaotic. It is a sign of connection, one world responding to another. As you let this sink in, notice how calm the feeling is. You are learning about magnetic fields and solar winds and particle streams, but there is nothing alarming here. These forces have been shaping Earth's skies for billions of years. They are familiar companions, not threats. In their movement, there is a steady rhythm, a balance between energy and tranquility. And after all this motion and energy, a silence returns. As this journey through the universe gently settles, let yourself drift into a quieter space inside your mind. You've traveled far, across galaxies, through fields of invisible matter, along the glow of ancient stars, into the earliest light the universe ever released. You've followed particles that pass through your body every second, watched galaxies merge like islands in a cosmic tide, and looked back to the beginning of all structure. But now, instead of moving outward, you turn inward, toward the simple truth at the center of everything you've heard tonight. You belong to this story. Take a slow breath. Let your shoulders drop a little. The universe is vast, yes, but its story is not separate from yours. It is written in the same language: light, matter, motion, time. Every chapter you've explored is connected gently, quietly, to the atoms inside you. And those atoms hold a history older than Earth itself. The carbon in your muscles, the iron in your blood, the oxygen you breathe with every inhale, the calcium in your bones. All of these were created in stars. Some in stars that lived normal, steady lives. Others in stars that exploded in spectacular supernovae, sending their inner layers into space like seeds carried by the wind. Those scattered elements drifted for millions of years, then settled into clouds of dust. From those clouds came new stars, new planets, and eventually, much later, you. When you understand this, your story starts to feel less like a footnote and more like a continuation. You are not a visitor in the universe. You are a piece of it, rearranged, alive, and aware. Carl Sagan's words echo softly here. We are a way for the cosmos to know itself. Tonight, those words feel less like poetry and more like a simple fact. Everything you've learned about galaxies, about light, about particles, lives in you already. And when you listen to stories like this, the universe is remembering itself through your curiosity, through your wonder, through the calm that settles over you. As you begin to let go of the day, notice something. The universe keeps moving even as you rest. Right now, as you lie back and breathe, your body is orbiting the sun at tremendous speed. The sun is orbiting the center of the Milky Way. The Milky Way is moving toward the Andromeda Galaxy, and both are drifting through the Laniakea supercluster, following currents laid down billions of years ago. Everything is in motion, yet everything feels still. You can imagine it if you want. A slow, majestic drift through space. Your planet turning beneath you. The moon pulling gently at the oceans. The sun radiating warmth. The galaxy rotating in its vast spiral. You are carried effortlessly by all of it. You don't need to steer. You don't need to try. In this moment, the universe is moving for you. And while you sleep, that motion continues. Steady, predictable, and safe. Stars burn quietly. Galaxies glide along filaments. The CMB hums softly in every direction. Neutrinos pass through you by the trillions. Cosmic rays ripple high above the atmosphere. All the processes that shaped you. All the forces that sustain you. All the cosmic rhythms that give the universe its structure. They keep unfolding while your eyes are closed. The story doesn't stop just because you are resting. It flows around you, through you, and alongside you. And knowing this, you can let yourself relax a little deeper. Tonight is not a night for questions or problems or decisions. Tonight is a night to feel small in the best possible way. Small enough to let things go. Small enough to feel held by something larger. Small enough to rest. You've traveled across billions of light years. Now you can simply arrive, here, in this moment, with your breath steady and your mind slowing down. Think of the universe as a quiet ocean stretching in all directions. You're not lost in it. You're floating, supported, weightless, safe. As the last traces of thought settle, let the calm rise. You are made from ancient stars, gently shaped by gravity, illuminated by the same physics that guide galaxies. There is nothing you need to do now, nothing you need to fix or control. The universe has been moving for nearly 14 billion years. It will keep moving while you sleep. You've listened long enough to feel the shape of things. You've seen the vastness. You've felt the softness. You understand, in a quiet way, where you come from. And now, The final step of the journey. Let yourself become still. Let your breath deepen. Let your eyes soften. Let your thoughts drift the way galaxies drift. Slowly, gently, without urgency. You are safe. You are small in the most peaceful sense. You are part of a story too large to rush and too calm to fear. And as you close your eyes, remember, the universe keeps its own rhythm. It will hold you while you rest. It has always held you. Good night, traveler.